Okay, Assalamualaikum. In this lecture, we will be talking about simultaneous equation model. Now we find that in many economic relationships, there is a two-way or simultaneous relationship between variables. Unlike the examples that we have seen previously, that the relationship between the variables would be just one way, the explanatory variables affecting the dependent variable. But in many other cases, all right, the relationship between the variables is a two-way relationship. So to model such relationship, it would require more than one equation, right? And this all will be under what we call the simultaneous equation model. In simultaneous equation model, the variables would be identified or will be classified as either endogenous variables or predetermined variables, right? And predetermined variables would be either the exogenous variables or the lagged endogenous variables. Now, the difference between endogenous variables and exogenous variables would be as what it is say. Endogenous means in, exogenous means out. All right, so what exactly do we mean by in and out? Endogenous variables are variables of which the values are determined within the model, within the system itself. Exogenous variables, these are variables that are that the values of these variables are determined outside of the model. So they are predetermined. What about lagged endogenous variables? Because it is lag value, it means it has already been predetermined before that time period. So predetermined variables consist of exogenous variables as well as lagged endogenous variables. Okay, when we are dealing with simultaneous equation model, we cannot apply OLS as the method of estimation because the error terms in the equations as well as the variables on the right hand side, they are correlated with the variable on the left hand side. Here we say that we have a problem of simultaneity. If we insist on using the OLS method of estimation, the OLS estimators will be actually biased and inconsistent. Therefore, the estimated values will not be good estimated values. Okay, so the simple way of explaining simultaneous equation model is just to give you examples, and we'll just stick to just simple examples. So the market equilibrium model as well as the simple macro model. Okay, for the market equilibrium model, we have the demand equation as well as the supply equation, and we have the equilibrium condition, right? So over here, this is our structural model, and beta naught, beta 1, beta 2, gamma naught, gamma 1, these are our structural parameters. Okay, so we look at our demand equation as a function of price and income, and supply equation, let's say, is a function of price. So over here, okay, what we are interested is to estimate this demand equation as well as the supply equation. Over here, you can have another example, your simple macro model, where you have your income from the expenditure side is equal to, all right, is defined to be your consumption plus investment plus government expenditure plus export minus import. Okay, and here you have your consumption, all right, is a function of your disposable income. Disposable income is your income minus the tax that you pay, right? And the tax is just a proportion of your income, and the investment is dependent on the returns, rate of returns. Government expenditure, let's assume that it is given predetermined. You have your exogenously determined. Okay, some set at some level, and your x minus m, your next net export, is dependent on income. Okay. So in this case, what would be the endogenous variables, all right, and what would be the predetermined, or which consists of the exogenous variables as well as your lagged endogenous variables. Okay, the endogenous variable for this market equilibrium model will be your quantity demand, quantity supply, as well as your price. Okay, the exogenous variables will be your income level. There is no lagged endogenous because there is no lag for your quantity or your price. There is no PT minus 1, PT minus 2, and so on, as well as there's no QT minus 1, QT minus 2, and so on, right? So for this case, the endogenous variables will be your quantities as well as your price, whereas the exogenous variable will be your income. For the macro model over here, all right, we have a lot of endogenous variables. The endogenous variable will be your Y, will be your C, will be your I, will be X, will be M, as well as your T, as well as your R. Okay. While the exogenous variable over here will be your G bar. Okay. Again, there is no lag endogenous variables. Okay. So the equations that we're interested to estimate would be this consumption equation, this equation, this not this one, all right. Over here also no, because if this t here is already predetermined, the rate is given, so we're not interested. This is just the equation that defines the tax rate, but we would be interested to find beta naught, beta 1, as well as mu naught and mu 1. So the next thing that we want to also understand when we talk about simultaneous equation model is the difference between structural model, right? Structural model is what you have seen before. It is the structure given, the relationship, assumptions of the relationship between the variables. We have written, the equation, the model as what you have seen before, the market equilibrium model, as well as your macro model. All right. For structural model, you have your endogenous variables appearing in both the left-hand side as well as the right-hand side of the equation, and you have your structural parameters and as well as your structural errors. Okay. Now, we can also talk about your reduced form model. The reduced form model is we rearrange, all right, your structural model so that the endogenous variables are expressed in terms of the predetermined variables only. Okay, so then we will have what we call the reduced form parameters. Okay, so the example that you have seen before, right, your market equilibrium model this is what we call the structural model. Okay, so here you have your quantity demanded as well as your price. All right, so your endogenous variable appears on the left hand side as well as your right hand side. This one, your supply, quantity supply, another endogenous variable. It appears here as well as your price appears on the right hand side. So the endogenous variables appear in both the left hand side as well as the right hand side. This beta naught, beta 1, beta 2, gamma naught and gamma 1, these are what we call the structural parameters. Okay, and this U1 and U2, these are what we call your structural errors. Okay, so what we want to do here is that we want to rewrite these equations, all right, so that our demand equation, for instance, QD, is just a function of your Y, all right. of your predetermined variables income. Similarly for the supply. Okay, so this is just doing the math as what you have done before. All right, just the algebra. And so what we can do is, for instance, because QD is equal to QS, so you take this equation and equate it with this. All right, if this is equal to this, therefore this would be equal to this. So you write it this way, and then you can solve for P. Okay, so you just combine, put the P all on one side, right, and put your predetermined variable. In this case, it's just Y. So then you divide everything by gamma 1 minus beta 1. Okay, so you have this, and you have this, and you will have this. All right, so we can rewrite all of this thing. All right, put it as pi naught. All right, this thing over here is just pi 1, and this error term, all right, combination of your structural errors, this would be another error term. Okay, so in this case, you will find that what you have done is you have written the endogenous variable in terms of your predetermined variable. Okay, and you can do the same thing for your Q. Okay, so when you do your Q, you can just substitute. All right, so this is Q, for instance, this one. You can now replace this P with what you have over here. So we will have this. Okay, and then we can just do some simplification, and you have this gamma naught plus gamma 1 pi naught. We can put it as pi 2. This gamma 1 pi 1, we can write it as pi 3, and this would be your error terms. Okay, and put it as just 1. Okay, so from here, this now, all right, this pi naught, pi 1, pi 2, and pi 3, these are what we call the reduced form parameters. Okay, so this would be this new, or you look like it's V. All right, this one, and this one would be your reduced errors. Okay, your reduced form errors.